In this portion of the demonstration, we're going to take a look at what I consider to be a little bit more complex type of machine tool. That 5-axis was not too bad, but what happens when you get into those multifunction mill turn type machines? Well, I've got one of those here. I want to kind of show you what we can do with that. Oftentimes, when you get a part like this, it's not the part that's so complex. If I'm going to zoom up in here and take a look at this part itself, this part's actually fairly simple in its geometry. It's a turn part with some flat cuts and maybe some off-angle holes and surfaces on it. But there's nothing here that's really difficult to machine. If we look at the machine paths, the operations that we've created, we'll see that we've created a number of them for the main spindle, and we've created a number of them to go on over here on the sub spindle. We look at this, we've got a main spindle, a sub spindle, we have a lower turret, and we have an upper head. The difficulty is not in creating the paths, but the difficulty is in how do you make all of this stuff work together at the same time and ensure that you don't have things that run into each other, that you don't hit the spindle on the other side, or that you don't have tools running into each other, and also that you get an efficient usage of all of this. Well, the way we do that is with a product called the Synchronization Manager, and that's also embedded right inside our CAM software as well in NX CAM Express. Let's go in first, and we will take a look at this. We'll say, let's go look at this tool path in the Synchronization Manager. And so it's loading all of this in. It's actually post-processing and looking at it and saying, okay, how would all these things go together? Now remember kind of how this looks here, because when this first comes up without any synchronization at all, it's going to look very much the same in the Synchronization Manager. So what we've got is two separate channels for the two different chucks, the two different spindles we've got here, chuck 1 and chuck 2. And then we see which of these operations go with which one. Now, we see the time that it's going to take to run these, and if we were to run this right now, which I'll do real quickly, I was going to put this down here so you can see this run very quickly. Let me move this over here out of the way. We've got things going on helter-skelter, and not a very good efficient use of our time. We probably may even have some things running into each other, things going on both ends, and we've not synchronized things at all. We don't know which is the controlling turret or spindle or any of this, and so it just kind of runs through, and we've got some real slow times through this because one side's waiting on the other. And this would be just kind of the out of the box start way to type doing this without any synchronization at all. And I'm actually not even going to let this finish. I'm just going to go ahead and stop it. What we would really like to do is run this in a synchronized mode. Now we've gone through, and in this toolpath I've got some synchronization marks in there. And as it goes through and reprocesses this again and looks at it, we're going to take a look at that synchronization and how you put that in there and how you would move those around and how you make these things synchronized to each other and what effect that has on things. So again, it's going through and posting and figuring out the times, and now you see these little green marks in here, and these are our synchronization marks. And now we've gone through and pushed those from between the two spindles and the different channels so that we can now make things happen where we want them. Now you'll notice, again, we're looking at the operation level. Maybe kind of hard to tell what's going on there. So we can go down, not from the operation level, but we can go down to the actual events. An event would be like a linear move or a tool change or a start of path. You can see these different events on here. Another way, the thing that we have to help us see this is we can look at this in kind of a full layout of how they relate channel to channel, and we can go here and look at, okay, if I'm here, what's the code that's going on in things up here, or if I want to go over here, what's happening between the two different ones, and see that in a graphical manner as it's laid out. But again, this may not be an easy way for you to look at it. You may not say, well, I don't really want to be able to move a synchronization mark here. I want to see it in G-code. We can also do that. We can show it in G-code, and as you go back and forth in through here, you'll see the different G-codes at the different place. And you'll see these synchronization marks. Now the way we synchronize from one side to the other is we can grab these and say, okay, I want to move this someplace else. In this case, I'm happy with where it is, but it's just a drag and drop of these synchronization marks, or you can add another one in wherever you'd like. And then we can see how these things work together. Now I'm going to turn this legend back off down here because we need a little bit more space to look at this. I turn that off so that goes away. Now we're going to simulate this again. I'm just going to go a little step at a time and talk a little bit about what's actually happening down here with the machine tool. So we'll go one step. We get our channel window. Again, this is similar to what we saw in the machine simulation. Feedback as to what's happening, the status of the machine tool as it goes. Now this goes kind of fast, so I'm going to slow it down just a little. And what you're going to see is just as it runs down through, you'll see, first doing some turning on this side and turning on that side, and then as we turn back and forth and we have these things synchronized together so that we can control what's happening on which side at each given time. We can work on both sides simultaneously. We can work on one side at a time. However we need it to go to get the best usage of our machine and also the tools that we're using. See, when we come down to do some of this milling, it really wouldn't do a good idea to take this turret and drag it to the other end because we'd go right through that head. So this gives us the ability to graphically see and simulate all of this. Okay, I'm going to speed it back up a little bit now. Now here at the end, we come and do some work on this end while we're indexing that. And you'll see we're going to index and move this turret over this side and just park it so that it's out of the way of the spindle. We're going to use a large tool. If it were over here, it'd be hitting this chuck every time the chuck moved around. Now we're going to do our work on this end, park the spindle, and then come back. We have that level of control with the synchronization manager. This allows us graphically to have a nice layout to be able to control and use and predict what's going to happen on these very complex multi-spindle, multi-turret, multi-head machines.